Resilience of Point Pleasant Park: 2 decades of forest succession following Hurricane Juan.
We would like to begin this presentation by acknowledging that Dalhousie University and Point Pleasant Park are on traditional Mi'kmaq territory. Dalhousie and the biology department have worked to integrate Indigenous perspectives and ways of knowing into the lab component of the course to show respect and reverence for the land and cultures of the First Peoples. Our research is analyzing the secondary succession in Point Pleasant Park after Hurricane Juan came into contact on September 29, 2003. Due to the substantial damage that occurred with the hurricane being a Category 2, the forest was not able to withstand the disturbance caused. With shallow soil and the forest being even-aged, there were no younger trees to cover older trees from winds, which led to an uprooting of a large quantity of the forest. After the hurricane, studies began to observe the succession of the forest post-hurricane. Succession, by definition, is the ability of an ecosystem to change or recover after a disturbance. By reading studies like Turchin's from 2016 and Berg et al.'s study from 2018, we are able to further understand how succession occurs in a forest over time. Throughout this presentation, we will take data collected from Point Pleasant Park, or Amtukati, and analyze it using graphs and regression equations to develop a thesis on the succession of a forest over a period of 18 years. By exploring and developing this data, we will answer how well the forest has been able to recover after Hurricane Juan and predict what will happen to the forest in the future. Not only this, but with the important historical sites of its past as a military base, the park being a place for connecting to the land in downtown Halifax, and the inhabitants of many animals that thrive off of the park's resources, understanding how succession progresses in Point Pleasant Park can further our ability to preserve the forest's biodiversity in the future when a disturbance occurs. To explore the succession of Point Pleasant forests, we created a hypothesis for our future findings and graphs and calculations. Our null hypothesis, also known as HO, is that there will be no significant change in succession over time, and our predicted hypothesis, also known as HA, is that there will be no significant increase in succession over time. Based on these hypotheses, our goal for this presentation is to analyze the data we've gathered in order to either reject or fail to reject our hypothesis related to our specific questions in our results section.
Data collection was carried out in designated 10 meter by 10 meter study sites within Point Pleasant Park, concentrating on 2 primary types of data: tree measurements and ground flora assessments. We were assigned Site 5 at the park to measure its communities after Hurricane Juan damages in 2004. All living trees with a breast height diameter of over 2.5 centimeters were measured 1.4 meters above the ground, following industry standards, to estimate wood volume and enable comparison with logging data. We used a measuring tape to take the trunk measurements to the nearest millimeter with the help of iNaturalist and a species manual found at the park to identify the specific species. For the ground flora, the percentage cover of each species was assessed using 12 randomly placed 1 meter squared quadrats. To establish each quadrant, a group member tossed a brightly colored object over their shoulder to randomly determine the sampling location. We also used the same material to identify ground flora species. This process was repeated for 12 quadrants per study site annually, with percent cover estimates reached by consensus among group members and recorded on a data sheet. The data of all the 6 groups were compiled and added to the 20-year data collection.
After the destruction of forests and communities due to Hurricane Juan in 2004, the Shannon Diversity Index, measuring both abundance and evenness in the species of Halifax, Nova Scotia Point Pleasant Park, made a drastic increase between the 18 years the community was monitored. Basing these facts on the quantitative values taken from Figure 3 above, the R2 is equal to 0.3352 and the p-value is equal to 2.3 times 10 to the negative 8. With a p-value less than 0.05, this confirms that we are able to reject the null hypothesis, which declares that there is no change in succession over time, and our prediction is deemed accurate. It may be taken into account that though there may be fluctuations in the Shannon Diversity Index due to natural disasters such as hurricanes, heat waves, and other hazards like climate change, it is likely that once the forest moves towards the climax community, the index will plateau. By reaching a climax community, the members of the community reach an equilibrium of nutrients and allocation of soil, and the community will remain unchanged unless a disturbance of the environment occurs which will cause a secondary succession. Some examples of secondary succession due to disturbance are instances of overgrazing of animals, long-lasting droughts, and wildfires, which kill off species and may lead to intra- and interspecific competition for resources throughout the ecosystem or a heightened death rate. It is also important to recognize the distribution of species as the forest reaches climax community. As Nelly et al. Mentions, concerning the forest ecosystems of Point Pleasant Park from 2004, the 30% of the remaining tree density of the Point Pleasant Park was the first step in recovery in the park. These remaining trees will continue to aid in the recovery of new growth of their seed in ways of natural regeneration of the forest and will disperse less as the plateau of the equilibrium occurs. Not only this, but as the community reaches a climax community, there will be little to no introduction of new species to aid in the recovery, which was quoted by Neely et al. From 2004.
The aftermath of the devastation and displacement of populations in 2004 has led to a significant increase in the density of red spruce within Point Pleasant Park, marking a resurgence of this species. Over the years, a clear trend has emerged indicating substantial variations in red spruce density per 400 meters squared. This suggests that certain plots may exhibit superior soil quality or other favorable conditions for growth. The R2 value of 0.1128, as shown in Table 2.1, reveals that approximately 11.2 of the observed density growth can be attributed to the events of 2004. However, other factors such as random variation and evolutionary adaptations are also likely to influence these changes over time. According to the literature by Keyes, various factors can influence the likelihood of a specific successional pathway occurring. These factors include the species composition and maturity before and after a disturbance, the availability of advanced regeneration, the proximity of seed source, and the conditions of the ecosystem, further proving that many factors play a role in the changes noticed. Linear regression analysis was utilized in this study as it effectively captures the relationship between independent and dependent variables, providing a solid framework in understanding these ecological dynamics. Based on the trends seen in Figure 2.1, we can predict that the density of red spruce will keep continuously growing as seen in the linear regression. Over the years, a clear trend has emerged in the red maple density, highlighting significant fluctuations per 400 meters square, with marked peaks observed until 2022, followed by a stabilization phase. Compared to Figure 2.1, the growth of the red maple is significantly more pronounced, suggesting a larger population than that of the red spruce. This observation implies that either the soil quality and other growth conditions have become more favorable, or that red maple has developed adaptations that enhance its suitability relative to red spruce in the post-hurricane environment. As illustrated in Table 2.1, the R2 value of 0.1549 indicates that approximately 15.4% of the observed density growth can be attributed to the events of 2004. However, other factors including random variation and evolutionary adaptations likely contribute significantly to these changes over time. Burley's 2008 study on Point Pleasant Park noted the possibility of local phosphorus limitations that could account for the variations in soil fertility, thereby helping to explain the fluctuations in density, particularly in the absence of woody debris on the ground. This study employed linear regression analysis to effectively capture the relationship between independent and dependent variables, providing a robust framework for understanding these ecological dynamics. Based on the trends seen in the Figure 2.2, we can predict that the density of red maple will keep continuously growing as seen by the linear regression.
Community metric within the forest significantly increased in species richness, R-square value of 0.61 and p-value of 2.2 times 10 to the negative 16 at significance p equals less than 0.5 through the years 2004 to 2024, shown in Figure 1. The indicated data results shows the species richness in the designated area at the park increased over 20 years. Burley et al. 2008 discovered after natural disturbances, vegetation can quickly recover and some species dominate the early successional stages. This could lead to dominating species like red maple to increase in richness in those specific areas. Generally, the data collected follows the successional trends observed after natural disasters. Turkin 2016 also noted the number of trees at Point Pleasant Park had increased 40 times as much during her study. She also explained why the abundance of trees had increased. The observed reason was trees had established a canopy, not allowing the ground plants to grow. We can predict the tree community to dominate in later times because of succession, and we would see more abundant trees and very few ground flora. Trees have longer root systems compared to ground flora, resulting in trees winning interspecific competition between both species. Finally, trees are shade tolerant compared to ground flora. The bigger the trees get in height and establish the branch systems, it prevents the sun to reach the ground and blocks any important nutrients for ground flora to grow. Berg et al. 2018 also concluded that shade-tolerant species like trees saw an increase in population compared to other species after 20 years. To conclude, the community saw an increase in tree richness as the years progressed, and we can predict to observe the dominating species to be trees when the community metric moves towards this climax community. Based on the observed trends in our data, we can predict that the forest is in the mid-succession stage as the forest moves towards a more mature state. Point Pleasant Park being an urban area makes it harder for species progression. Pollution and anthropogenic activity like walking in the area can affect soil health, can limit growth in the area. Another example for why urban park can inhibit growth would be park management plans. We might want to later grow more plants to keep the forest density more appealing to the public, but we need to be careful that we don't introduce invasive species in the area because it would compete against the native species. In conclusion, we should integrate Mi'kmaq values like to Ising concept. This concept explains we should integrate the Western strength and Indigenous
All
strength
right.
to obtain maximum benefits
Yes.
for all of us.
Um, I mean, I'm doing homework right now.
Following the
But
stages of succession, reaching the
I'm in
climax
environmental
community indicates
science.
an equilibrium between
Yeah.
species in an
Okay.
ecosystem where
Second.
populations of species exist in
Yeah.
balance with each other and the
No, no, no.
environment. The
I'm from
equilibrium
Timmins,
is indicative
Ontario.
of a balance between
Yeah.
species populations and their surrounding environment, where species
Yeah. Well, I
richness,
mean, it's
abundance, and
much better
evenness are critical
than
measures
Timmins.
and metrics for
So.
assessing proximity to the climax stage.
Yeah.
During mid-succession,
Yeah.
several key
Yeah.
indicators suggest the ecosystem is progressing towards this equilibrium. For instance, a
Okay.
notable increase in species diversity
Yeah.
and
Yeah.
the establishment of more complex
Pardon?
interspecific relationships can be observed. Additionally, these ecosystems often demonstrate
I'm
fluctuating
I'm
levels
I'm
of
I'm a
resource
Habs
competition
fan.
as both established and newly introduced species compete for resources such as light, nutrients, and
I'm
space.
just it's just a
Highly
family. It's just
competitive
a
levels,
family.
particularly for limiting resources, may signal that the community is
Exactly.
maturing, prolonging
Nice
the
to meet
time
you.
frame for reaching climate stability. The interplay between colonizing species and
Okay.
more
Yeah.
established ones can lead to a dynamic shift in community composition, ultimately influencing the trajectory towards a climax state. In totality, evaluating these mid-succession indicators is essential for
Perfect.
understanding the pathways and timeframes
Perfect.
necessary
Thank you very
for
much.
achieving ecological balance
No,
within a
I'm the
given
only one.
environment.
Yeah.
The red maple density graph, as seen in Figure 2.2 earlier in the slides, reveals a notable trend of increasing density following hurricane events, highlighting the species' remarkable resilience and
Perfect.
adaptability to ecological disturbances. In
Perfect.
the
Thank you very
aftermath of
much.
significant
You too.
disruptions, particularly following Hurricane Juan in 2003 and the other disturbance events of 2005, 2007, and 2016, the red maple population has not only survived, but it has thrived. This indicates that despite forest thinning caused by storms, we can expect rapid regeneration of red maples, which renders any changes in forest compositions nearly imperceptible. Furthermore, red maples are prolific seed producers, suggesting that such disturbances may enhance seed propagation and dispersal. The increased availability of light and resources after a disturbance likely facilitates seed germination, promoting further growth rather than a decline in forest density. Considering these factors, it is reasonable to anticipate that red maple will retain its dominance in the ecosystem, contributing to a dynamic yet stable forest structure that responds robustly to environmental change. This adaptability not only emphasizes the species' essential role in the forest, but also indicates that it will continue to shape the landscape, even in the face of storms and hurricanes.
Removing deadwood can remove nutrients, remove species habitat, and increase soil erosion. If the debris is left in the forest, the wood decomposes into the soil and provides important nutrients for plants to grow in early stages of succession. Deadwood debris also provides habitat for living organisms, and cleaning it up can strip possible habitat, adding diversity and richness to the forest. Finally, removing the debris can open surface areas, increasing the chance for physical weathering or chemical weathering in the soil. The erosion results to washing nutrients away from the area, affecting growth in certain species. Cleaning up debris in the area has an overall negative impact, and we need to consider it if cleaning up debris making the park more visually pleasing is worth the negative effects in forest diversity.
We would like to give several thanks to individuals who helped us complete this project. We primarily would like to thank Alison Schmidt and Rajesh Selvam for not only giving us the knowledge to properly develop our presentation with well-developed concepts that can be used in and outside of the classroom, but giving us the tools like curated graphs and regression calculations for accurate representations of findings from the forest. We'd also like to give thanks to our TA, Max Henry, who has been extremely present and helpful during our lab times with giving us guidance towards a better understanding of complex concepts. Equally as important as the Dalhousie faculty, we'd like to thank the Mi'kmaq community who has allowed us to collect the data from the Amnutkati, as they are sacred grounds for animals and plants alike.